In this video, I'm going to go through the half-yearly or mid-course review for the 2020 HSC Engineering Studies. So it's all maths, and what we're going to do is we're going to start off with question 1. It says a block with a mass of 23 kilograms, so straight away I can say mg equals 230 newtons, is pulled by a force of P equals 100 newtons at an angle of 30 degrees. Okay, this is a bit harder than any other question that I've done on bear in the box, because in this case P is given, but what are we finding? We're finding mu. Mu is the unknown. That is the worst mu I've drawn, but it'll do. P equals 100. So because it's at 30 degrees, straight away I can split that up into its component forces. I'm going to call this pH equals 86.6 newtons and PV equals 50 newtons. That's because it's a regular value, and we use those sizes all the time, so that shouldn't be a surprise. We're making the box lighter, not heavier, so we're going to write so we always use the formula F equals mu n, but I like to rewrite that formula as the Phony friction formula, which is pH equals mu and then mg plus or minus PV. So in our case, we're going to write 86.6 equals mu 230, and in this case we're making the weight of the box lighter, so we're reducing the normal force. So, and PV equals 50 newtons. Okay, so that's going to be 180. So in that case, what we can say is that mu equals 86.6 divided by 180. To keep this going fast, I might get people to help me with the calculators. So if you can, I'll do this one, but in future, if you can sort of follow along. The idea here is that I'm going to be getting students to fill out, and I want them to get a full marks, so 0.48. And that seems like a pretty reasonable coefficient of friction. It makes sense, so I'm happy enough with that. We can move on. That was worth, I made that worth 2 marks. That's well, I think it's probably worth 2 marks. I said it is harder, and that's because we very rarely are asked to find mu, but as long as you know how to do basic algebra, you should be able to figure that out. Okay, this question is a bit more difficult, but it's not as difficult as what I gave last year. So this is 1b. So again, we're saying that the boat equals 800, so mg equals 8,000 newtons. The slope is 20 degrees. Mu equals 0.4, and we're calculating the force. Now it says here to just prevent the boat from slipping. So in this case, friction is reducing the amount. So imagine if I'm pulling on a boat or pulling on a rope, and I don't want that boat to slip away. I'm thinking, thank you, friction. You are making me have to apply less force. So in this case, we're going to minus the force of friction. Friction is going to reduce the amount needed. Now, I could go into a complicated formula, but I've spoken many times about the too many guys formula, which is effectively we could think of this as mg sine theta plus or minus mg cos theta, mu cos theta. Okay, and so mu cos theta is the friction component, right? I remember this as mucus, so I simplify this a little bit as sine, I wrote m instead of mu cos theta. Okay, so I've got the story, there were too many guys on the boat, hit my head in the sine, then got sneezed on, mucus. Okay, in this case, we can say that because friction is helping us, that's going to reduce the amount of tension on the rope, because friction is helping us. So I then just add in those details. So we've got 8,000 sine 20 degrees minus 0.4 sine cos. Someone should already have this, please. What we got? Good work. Okay, so 0.4 cos 20 is what I'm typing in first. It gives me 0.37. And then I'm going to go sine 20 equals 0.34 plus the previous answer gives me a total of 0.68. 0.68 times 8,000 equals 5472 newtons. That seems about right. Okay, that was 3 marks. Without the too many guys formula, this is relatively difficult, but in several occasions we've talked about this is the component of weight that's sliding the boat downhill. This is the friction that's caused by the normal reaction. Okay, with that we're going to move on to question 2. This question was question 1 was the least well answered of the in the exam. Okay, question 2. I'm going to assume this part A. Okay, so this question I think was literally given. No, it's based on a multiple choice where you had to recognise the bending moment diagrams. I just made you draw the bending moment diagrams instead. So what I'm saying is you go up 9.4, you go across 3.5, so up 9.4. Then you go across, so 3.5 metres, across 3 metres to, this is still above the line. 9.4 minus 8 is 1.4. And then we're going to go down to 12, which is going to be to a total of 10.6. So that's how I would draw that. The diagram is going to look something like this. I know that from here, because this is a positive area, it's going to continue to go up. And then this area is going to bring it back down to 0. Because this is a negative area, when I add the negative area, it gets me back to 0. The height of this, can anyone give me either of these points?
$32.9.
Is this one?
37.1.
37.1. Okay, so the maximum shear force is this one, and the maximum bending is that one. Because we're generally, and so this is, they give you the units of kilonewtons and kilonewton meters. Those units were given. So, okay, I think it was pretty easy 3 marks, to be honest. I think I was generous making that 3. That could have easily been worth 2. This way, it was just that if you didn't label your drawings, I had another place for you to give me a mark. So,
well, this one's already got them.
Okay. Question 2b is a bending stress question. So bending stress equals my over I. So the information we need, they've given us M. They've told us that M equals 1.7 kilonewton meters, which we're going to convert to times 10 to the 6 Newton millimeters. So that's our M star, or our maximum M. The beam is shown as being 150 by 50. So that means that if our neutral axis for a rectangular beam is halfway down, so that means that Y for compression equals Y for tension, which is equal to 150 divided by 2, which is equal to 75 millimeters. Then the I is given to you, 14.1 times 10 to the 6 millimeters 4. Okay, so if I just plug those numbers in, shear B equals, now, even if you just did that, if you wrote the formula and wrote some values for the formula, that's at least 1 mark out of 2 mark question, right? If you just wrote, even if you only had, if you didn't have Y, I'm still going to give that 1 mark because you've shown me some knowledge. You've shown me more knowledge than someone who's written nothing. You've identified and read from the question, you know that this value goes there, and you know this value goes there. You don't know what Y is, but at least you took a shot at it. So that's just an exam technique thing. So what we're going to say is 1.7 times 10 to the 6 times 75 all over 14.1 times 10 to the 6. That crosses out. Answers should be about 9 megapascals.
9.04.
Where is it?
9.04.
9.04. Now, as you know, because we're using millimeters, we get our answer in Greece units. We go together like megapascals and millimeters squared. Okay, I think that question is actually answered relatively well because there's only really 3 parts.
I had the right idea, but I forgot the 10 to the 6.
Hey, the 10 and 6s should cancel out. I think that was somewhere where you lost a mark because I think you did 10 to the 3. I don't know if that was enough for you to lose. Well, we'll see. Okay, we're now on to question 3, which is about efficiency. So when we talk about efficiency, that's not a very good eta. I always write my etas curling the wrong way. Eta should be more like that. Equals MA over VR. So we say that MA equals L over E, male, most people get that, and VR equals the distance traveled by the effort compared to the distance traveled by the load.
NREV.
Most people get this, yeah, NREV comes into it. So most people get this first part. So they say the load versus the effort. Well, the load in this case is 70 divided by 450. No tricks here, I didn't do any angles or anything like that. And in the case of bikes, you know that you should be getting 0.0 with 4 digits. What number?
0.1556.
0.16 what?
1556.
1556, like that? Okay. Now the next one here, what we need is the distance travelled by the big wheel compared to the little wheel. So remember when we're talking about load and effort, what we're talking about here is the effort is where the human or the engine applies. So in this case, the pedals is done by a human. So we're interested in the distance travelled by the pedal, not by the crank, right? If we're told this is 170, that means this distance travelled by the pedal in one rotation is going to be 170 times 2 times pi. Yeah? Because pi times diameter gives us the circumference. For the big wheel, on the other hand, it's going to turn around several times. How many times will it turn around? Well, they've told us the diameter is 700, but what we need to know is what is the gear ratio. So if we can just compare teeth, we can say, well, it's going to go 50 divided by 20, which is 2.5. That's the NREV that someone mentioned before, right? NREV is 50 teeth divided by 20 teeth, which means this is going to go around 2.5 times. So what have I got? I've got 2 times 170, 340 pi, divided by 700 pi. The pi's cancel out, so you don't need to write them. If you didn't write pi, I don't care, that I won't take marks off from that. 340 divided by 270 is half, but then there's this kicking in as well. So it's going to be, what's our number?
1.2.
1.2? No, it has to be a number bigger than this.
1.943.
1.943, that sounds about right. Okay, so, is that right?
Yeah, 0.1.
Okay, so now our efficiency is going to be 155 divided by 0.19.
1.9.
1.9.
0.9. No, it is 0.1943. I don't know why. So it was saying 1 point. Blah, 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 blah.
Sure, moving on. I may have said the wrong thing, sorry camera. Okay, and so that's going to be 80%, right? The answer is going to be 0.8. We did this question. The HSC question didn't ask for efficiency, but Facebook, we'd gone through this in the past and we'd gone through specifically. So if you looked at Facebook, you would have seen that detail there. So that's for question A. Now we're going to go, well, I just wrote A, but I'm about to rub it out. Okay, so we're now on to question 3B. A steel section under load. Okay, so what they're asking is calculate the area. So what we've been given here is we know that this E equals, so Young's modulus equals stress over strain. Now, in other cases, in most other cases, we use E equals flee. That's not given in the formula sheet, and in this case, that's not going to help us. This is a hard question, but I identified as a hard question on our Facebook examples and gave solutions of how you're going to do this. Now, in this case here, they've told us in our data, right, what have they told us? They've told us that the load, F, equals 700 newtons, right? So they've told us A is unknown, stress equals force over area, and we've said the factor of safety, 1.8. The allowable strain equals 0.0025. E equals 21 times 10 to the 3. Because it's gigapascals, we want to convert it to megapascals. Okay, so what we're going to substitute in here is we're going to say 21 times 10 to the 3 equals force over area divided by 0.025. Now, we are given the force, but I'm going to start with this. So I'm going to say that if we multiply these two numbers, we can start making it a little bit simpler. While someone's multiplying that, I'm going to say that, so what we can do here is we can actually say that if we know that E equals force over area like that, what we can say is that Young's modulus times strain equals force over area. And if we need to find the area, using our algebra, we can swap those two places. We can say area equals force divided by that. Okay, so what we're going to say is that area equals 700 is our force, divided by, what did we say this times this is?
525.
525. Okay, now, we have to remember that there's a factor of safety involved. The factor of safety is going to mean that the area gets bigger. So we're going to add on to that, we're going to add on here factor of safety, and we're going to add that on in the end. Okay, so 700 divided by 525 is 1.33 millimeters, pretty small, but then we're multiplying by factor of safety, which is 1.8. Which is 2.4 millimeters squared. Okay, I'm pretty sure that's the answer. Now, it's a small area, but it doesn't give you any context. So for a steel section to only have that area, it's pretty small, but they don't give us any context. So it's still reasonable. We're now on to question 4. Did I put the past trial, did I copy and paste it onto Facebook already? No, not yet? I just thought about it. Okay, so a couple of ways of approaching this question. We did a lot of practice on the three-force method. A lot of practice. And so I really tried to help people out by saying, trying to anticipate that, hey, we're going to be a question on three-force method. But, nobody likes the three-force method, so I guess I shouldn't have expected too much. Okay, so we've got this force here, RL. I'm using capital letters lower than lowercase. I think that's more
Trumpet.
Trumpet? What is blowing my nose?
Okay, no, they do in fact give us these are 60 triangles. Okay, now obviously because they don't specify every triangle, we can assume that these are typical equilateral triangles. It's very, very common that we're going to do that. So this, I want to draw your attention to, we do not know this angle. The one I've given you, I've asked you to find, is the one that's unknown. Right, that's really important. We don't know that angle. That's why I've drawn it as a wavy line. Right, not my world's best wavy line, but I'm too lazy to change it now. So, what are our ways of dealing with this? Well, here's how I would solve it. I'm going to get some colours. Just give me 1 second. Okay, so the colours we use, we go like this. Now, unfortunately this scale, my point of concurrency is off the board. A bit of a shame, but it'll be pretty apparent in a second that once I've found my point of concurrency up here, I can then, and I deliberately made sure the piece of paper was big enough that you could fit this on here. Once you've found the point of concurrency, you then go from here and you can line up from your point of concurrency to reaction, which will give you the angle, right? We'll call this phi of the this reaction. So maybe it's not immediately apparent, but if you've been doing these past three-force method questions we've been looking at, what you would see is what we get is a shape that looks a lot like this, where this is 60 degrees. X, what's that going to be?
6 meters.
Well, okay, so this height is the same.
What do you mean X? Oh, 1.5.
If this
yeah.
height is the same, right, we're going to call that height h, and these distances the same, and that distance is 60, well,
It's a 60-30 triangle, and then
those two
That might be
triangles are going to be
ratio.
symmetrical, yeah? So if you looked at that, if someone just drew these a couple of lines, they should be able to get 3 marks in a minute, right? They could look at it and they could say, well, measuring it out, it looks like it's the same, it's got to be 100, yeah? So unfortunately, though, I wish I'd drawn this at a better angle. I'm going to, just to drive this point home, in case it's not clear, I'm going to draw this diagram again. Okay, we've got some forces. Okay, this force is in the middle. Yeah, it's in the middle of that there. So what I'm going to do is I'm now going to extend these distances up. Point of concurrency. Point of concurrency. Once I've found the point of concurrency, I can then join the point of concurrency to where the reaction runs. And so with that angle, I can then figure out. I realise I've just drawn this arrow incorrectly. So the reason why we need that is we need an angle to balance. If this is going to the left, we need something going to the right. But just from that, I should be able to tell straight away that these are, in fact, these two forces are going to be equal. Okay, but let's assume that we're not going to it that way. Well, what are some other ways of approaching this question?
Taking moments.
Taking moments. Okay, there are 2 ways to take moments. Which way are we going to take moments?
From RL.
Okay. Taking moments from RL. So we're just going to jump straight into taking moments from RL. I'm okay with that. Other people might not be, but I'm okay with that.
You can take moments of
Well,
RR because
RR to find RL. That's how I bet you guys all going to need to do it. But me, I've got a plan, right? I'm a man with a plan. So I'm going to use my green lines here to show perpendicular distance. What I'm going to do is I'm going to get my set square, right? I'm going to get my set square out. And once I've got my set square, I'm just going to figure out what is the perpendicular distance here.
This one I remember going through those 2 end triangles.
Yeah, look, my angle is not great, so it actually does go through there like that.
Yeah.
That is
So I
actually.
remember I did some maths.
Yeah,
figure that
okay.
out.
Like, okay, that's fine. Just back off, man. Back off.
Well, I was just. Yeah.
Okay.
Come on, hit yourself on the head.
You know.
Okay.
Yeah.
So, to save you a bit of time, that's going to be root 3 times 3 meters, that distance, right? Root 3 times 3 meters. I'm pretty sure, right? This is 0.866, this is 0.866, that's 1.73 times a triangle, and the triangles are, but are we happy with that?
5.2.
Which is the same, type in root 3 times root 3? Or did you, yeah,
That is
yeah, okay.
yeah.
Yeah, I'm pretty sure that's the case. Now, the problem is we don't know that angle.
Cunning plan you have there.
Yeah, we don't know that angle. And if we don't know that angle, it means we can't use the perpendicular distances. Oh, looks like we're going back to finding RL first. Okay.
Yes. Big brain over here.
What was your plan?
Trying to cut too many corners there.
Look, well, I'm trying to demonstrate literally people who said we take moments about RL. They got excited, and for our case, it's not going to work. It will work eventually, but it won't work yet. Not until if we don't know the angle. So if you knew the angle using 3/4 method, but you weren't confident, this would be a way of checking. What we'd find is that the same distance, it's the same perpendicular distance from here to here if you know the angle. So assuming we don't know the angle, what we're going to do instead is we're going to take moments from RR. Okay, and this is how I think most people are going to solve it. Okay, so what we're going to do is we're going to say sum of the moments measuring from RR equals 0. I'm setting clockwise as positive. There's only 2 other forces to worry about. Now here, what we need to do is we need to either break this into distances or we need to figure out the perpendicular distance. So what's that going to look like? Well, a way of doing the perpendicular distance is if I told you this was 9 meters, if I told you this was 60 degrees, this was 30 degrees, that was a right angle, and this was 9 meters, what would that size be? 4.5. But we're not interested in that distance, we're interested in this distance, which is, so this is half. So this is adjacent, this angle is this side is adjacent to the angle. So we're going to say that it is 9 cos 30, which equals
7.8.
7.8. That sounds totally reasonable. 86% of that distance. Okay, so that's our perpendicular distance. So we're going to say, well, we have obviously RR times 0. We're going to have this here, which is 100. Okay, is that going clockwise or anti-clockwise relative to R? Is that going anti-clockwise? Okay, so we're going to say 9 cos, we do force times distance, that's how we do this. Force is 100, 9 cos 30, which we've written here as 7.8. So that's going to give me 780. Sorry, 78. 780. I go back to what I previously said. Then we're going to have RL. Is RL going clockwise or anti-clockwise?
Clockwise.
Clockwise, yeah. Okay, so plus RL. And how far away is RL? It's a triangle and a half.
It's a triangle and a half.
Yeah, which is 4.5. Okay, so it means that RL equals 780 divided by 4.5. What's that, please?
173.3.
173.3. Hey, that's a familiar looking number. Okay. So if we have that value, now what we can do is we can use the sum of the forces to figure out what is missing. Right? We could draw this as a diagram. We could say, if I had 173 plus 100, I could then draw a diagram and actually figure out what was missing. But most people don't approach it that way. You could, right? If I said this was going down, this was going up, the missing force, you could figure it out that way. You could say, well, you could draw it literally and just figure out what the value is and figure the angle out. But most people don't approach it that way. What they instead do is they do the sum of the forces vertically equals 0. Okay, how much vertical force do I have?
73.
Oh, if I have 100, if I break 100 into components, what do I get?
Sorry. 86.
Oh, 15.
86.6. Okay, so if I have 86.6, how much is missing?
2.
Oh, it's 86.6. Yeah? If I tell you that there's 50 to the left, well, that means we need 50 to the right. And once you start to see those numbers, you should say, oh, that's 100. Yeah, it's going to be 100 at 60 degrees. Oh boy, my saving is so... If you know your regular values, oh, it just saves you so much work. Now, look, I didn't draw that as neatly as I could have, right? So let me draw that up. 173... 86.6. What do we call this? V equals 173 minus 186.6 equals 86.6. So the sum of the forces vertically, sum of the forces horizontally equals 0. Well, I know that the component of 100, which we found earlier, is 50. So if I have 50, H equals 50. So then I can find H, wait. And we're going to find the angle. Angle equals tan to -1, brackets opposite. Okay. All of that seems like a lot more work than the way I would have done it. I'll also point out that there's one more way that you could do this, starting right from the top.
Wow.
What we could do is, instead of using this, what we could do instead is we could break this into its components right at the beginning, and we could say, replace that with 86.6 and 50. What we get is 86.6 times 9, and then that'd still be going anti-clockwise, minus 50 times 0. That will still, can you do that? 86 times 9? Pretty sure it's going to be 780. 86.6 times 90.
779.
Yeah, we're going to take that as being the same thing. So that's another way of doing it. Now, I appreciate I'm putting a lot of stuff there. This is a past trial question. I think this is from 2013. So you can look at the way they've solved it. I'm trying to do this in exam time, so I'm not going to go into any more detail than that. But this is a question that is either really simple if you know what you're doing. This really rewards people who know what they're doing. If you know what you're doing, it actually comes together really quickly. If you don't know what you're doing, it's a giant trap that you can find yourself getting really, really badly stuck. Okay. Okay, the next is a truss. So this is for B. You're right next to the camera. This is exactly the same as a question. I just changed the distances and the values. So this is exactly the same as a past HSC question. A, B, what are we finding? We've been asked to find BC and FD. So we're finding this one and this one. Okay, so the first thing I'm going to do is I'm going to cut through. I'm going to do a cut through here. I want to do a cut through here. I'm going to redraw my truss without the cut, or from to the one side of the cut. I've chosen to go with this side of the cut, and the reason I've chosen to go this side of the cut, the left-hand side of the cut, is not that there's less forces. It's because this one is not solved for us yet. This is an unknown, and I'd have to figure that out. So it's not particularly difficult to figure it out, and I'm happy to go through this somewhere else, but for the moment I'm trying to go quickly. So we've got 12, I mean, when I say you have to figure it out, it's going to be 4, right? It has to be 4. So it could be, I'm going to go through this way. Now, we've been asked to find our target is BC. We've been asked to find our target, which is BC. And what we want to do is we want to eliminate BF and AF. As I say that out loud, it should be pretty clear. What do those two things have in common? Well, let's have a look. As AF and BF, are they AF and BF? Are they parallel?
No.
No. So that means they meet somewhere in space. They're concurrent somewhere. Where are they concurrent?
F.
F.
Oh, yeah.
The fact that they say the same letter in the name, that's a pretty good clue, right? So we're going to call that point F. So what we now need to do is we need to measure points relative to F. Now, what I'm going to do is I'm going to measure my perpendicular distance, this distance here. I'll call it D, right? If in doubt, I'll call it D. So to show that, what I'm going to do is draw this triangle here, right? I have been told this is 30 degrees. So in that case, this must be what? If this is perpendicular, right, this is going to have to be 90 degrees. So what angle is missing?
60.
Thank you, everybody. Okay, if we're told this is 8, then how big is one half of it?
4.
I didn't need to remove that 8. Okay, so that's 4. So what is the perpendicular distance then? 2. Right, if we use 30, this is opposite, so we can say 4 sine 30 equals 2 meters. Right, so we have a perpendicular distance. So now that we have a perpendicular distance, let's get back to it. We have, this is a known distance, that's 4 meters. These two are eliminated because they pass through, they go to 0. The other force we need to know, we need a perpendicular distance here. We need to know this perpendicular distance here. Well, if this is 4, this is half of that, isn't it? So that's going to be 2. So So let's have a look from here. Sum of the moments clockwise, measuring from point F equals 0. If you get to that, because of the fact that you've told me F, and if you draw the cut line, I'm giving you a mark. Right? If you tell me the right location and a cut line, that's a mark straight away. You give me a perpendicular distance or 2, right? If you give me that calculation for perpendicular distance, that's 2 marks. Okay, 0 equals, now what is our force is 4 meters. 4 times, right, I like to do force times distance, that's how I do this. So I'm going to say 12 times 4 meters. Is that going clockwise or anti-clockwise? Relative to F? Clockwise, thank you very much. Okay, minus 16, now times 2. Is that going clockwise? Is the 16 going clockwise or anti-clockwise?
Anti-clockwise.
Okay, so it stays as minus. We have the BFs and AFs, they both multiply by 0. And then we have BC. Now we're assuming tension on BC. Is BC going clockwise or anti-clockwise? Okay, so we're going to write BC times 2, but we need to write in here that we're assuming tension. We don't need to write this, but I am. Okay, so now, as we continue that, so what we're going to have here is 48 minus 32. What's that? 16, sounds about right. Okay, so we're going to have 16... No. You sure?
Yes.
Sixteen times 2 equals 32. 48
Why is it
minus
times
32 is 60. Okay, so that's positive 16, right? So we need to bring it over here as minus 16. I'm just curious. Anyway.
That is a minus 16. Eh?
No, 48 minus 32 is positive 16, right? We're going to bring that over here and change the sign. So what we're going to say is 2 times BC equals minus 16. So that means it's not in tension, that means it's in compression. So we're going to say BC equals 2 divided by 8. Now it's not very clear handwriting because I'm excited. I'm going to say, so it's negative, therefore our assumption was no good, therefore compression. Okay, so that's how we solve that. There are slightly different ways of finding that perpendicular distance, but for the moment this is how we're going to roll with it. Now, FD, zero force member.
8/2.
Oh.
Thank you. Always better to tell me the mistake before I've moved past it so I can correct it on the camera. Okay, so, are you having a laugh at this point? No, okay.
Oh, a bit sick.
COVID.
Go home.
Okay,
Yeah, cool.
so, FD, zero force member. Right, there's a couple of ways of telling if something's a zero force member. I will link to some more videos in addition to the ones I already have because thanks to COVID, there's actually some really good resources in the last year that I've been watching and checking for you. But the fact is you should be able to recognise the 2 main forms of zero force members. We're going to worry about that later, but the answer is 4 in compression. By the way, I've given you all paper so you can be filling out your answers because you're going to be filling out answers.
I
Yeah,
didn't get.
photocopy. Okay, glad that we got to that when we're at question 5. Yes, we good?
Yeah. Wait, so
Yeah.
we say that D was a zero force member.
Yes, he said that.
Yes.
Yes.
Okay, question 5A. A 2-ton stationary vehicle on top of a 40 degree slope that is 20 meters long. Okay, so 20 meters long, 40 degrees is incredibly steep, like unrealistically steep, but we're going to run with it. Is this height, is that opposite or adjacent to the 20 degrees?
Opposite.
So it's going to be sine, so it's going to be 20 sine 40 degrees. Oh. We don't really need, sorry?
12.9.
12.9, H equals 12.9. That's 1 mark, right? Straight away I'd give that 1 out of the 2 marks. Pretty generous, but you know what? You've shown me something. You figured out height is important. Okay, so we've got mass equals 2,000 kilograms. Therefore, mg equals 20,000 newtons, which we can write as 20 kilonewtons, if we wanted to. We're giving our answer in meters per second, so maybe not. Okay, I just want to write all that information. Funnily enough, we probably won't need all of it. We know that PE equals KE in this equation. PE equals mgh, KE equals half mv squared. These are both on the formula sheet. Straight away, what we can do is we can see that we actually don't need mgh. And the reason for that is because the m's cancel. Right? We can include them if we want, but sometimes they don't give us the mass and we just have to figure it out without that. So what we're going to say here is 10 times 12.9 is going to be 129 equals half times velocity squared. So what I'm going to do is multiply this by 2. 2 times 129 equals v squared. And then if I take the whole thing, I get v equals that. What do I get? 16 meters per second. I think this was literally unchanged from the questions on Facebook. Okay. (5b). Okay, so in this case here, what we've got is a rider, and this rider, he has, I didn't specify the gender. Okay, so there is some mass, which is 180.
That's being filmed.
I'm just going to write mg for the moment. Mg, but, no, I want to write that here, mg. And then I need a perpendicular force, a perpendicular component, and this downward force. So we call this mg sine theta. We mentioned this earlier. We call this one here mg cos theta. The reason why we're interested in mg cos theta is that's going to be used to find our friction force. Our friction force is going to be Ff equals mu mg cos theta. Okay, but I don't think they didn't tell us anything about friction, so we just ignore that part. Yay! Life's a little bit easier, right? This is again is another question taken directly. I maybe changed the mass. I think that was the only thing I did differently. Okay, calculate the power required. Okay, so power, well, let's go back to black, like Amy Winehouse. Okay, power equals work over time. Work equals force times displacement. So we can say displacement over time is velocity, so we can say fight the power, Fv. This formula is not always shown on the formula sheet, it has been the last few years. You should assume to see it there. So what do we need to know? We know that V is given as 30 kilometers per hour, right? But we're going to convert that, we're going to divide that like head shear in by 3.6, which gives me 8.3 repeater.
Yep.
Meters per second. Okay, so what else do we need to know? We need to know the force. So the only force that this bike, because the friction is 0, the only force we have is mg sine theta. So F equals mg sine and theta. The problem is they don't give us an angle. Now we could figure out an angle, but instead what we're going to do is we're going to look at this. We're going to say that this is going to be the same proportion as this. Right? Now if we're told that this is 20 to 1, well that makes this 20 to 1. Yeah? That ratio is the same. Now here's the thing. So this is going to be mg, right? So this one here, well, I'm not going to write mg, that's confusing. What I want to know is I want to find this value here. But to do that I need to know this value. What is this value? If we use Pythagoras Theorem, we can say it's Pythagoras Theorem.
20 plus 1 squared.
20 squared plus 1 squared equals the square root of 401. Now the square root of 401 we're going to say is effectively equal to 20. So that means that mg sine theta equals mg divided by 401, which is basically equal to, or effectively equal, I see your hand, I'll get there in a second.
Yeah.
What is the mass? 100, so M equals 180, mg equals 1800 newtons. Okay, so we have 8 divided by 20 will be close enough, gives us 900. Right, that's our force, F equals that. 19.
No, 90.
90. Sorry, your question?
Yeah, it's only minor, but that, the triangles, the two triangles you got there, that 20 isn't meant to be the hypotenuse, isn't it? It's meant to be at the bottom.
No, I showed this. So when we say that, oh, yes,
Yeah,
right.
yeah, I was just
Thank you,
making sure.
great catch. Excellent, I'm glad you called that. Okay, so 20 to 1. When we talk about a slope being 20 to 1, means 20 along, 1 up.
Yeah.
So the problem is they don't give us the hypotenuse, we have a hypotenuse. We know the ratio of these triangles, right? We have similar triangles here. These triangles are similar. What we're trying to do is figure out the ratio. We're trying to see, well, if this is mg, and this is mg sine theta, what is the ratio of these triangles, right? And it's pretty close to 20 to 1. Now the fact is you don't need to do all this business here. You just, if they tell you 20 to 1, you're just allowed to say mg sine theta is equal to mg over 20, because if it's 20 to 1, just write 20.
Yeah.
Now, in the exam, for the HSC exam for this, their answers are wrong, and they say 2, which is wrong, right? And in my notes, I have put a little red circle around it and said actually 20, because it's 21. It actually should be the square root of 400, but we're going to say 20. Okay, so this number is going to be 90. That is possibly the worst number I've written on the board, at least today. Okay, so that's 90 newtons. So our power, back over here, or power equals, fight the power, FV, is 90 times 8.3 repeater, which gives us 750. Is that kilowatts? No, that's just watts, right? So power, and then I think the HSC did the same thing, so you've then got to write 0.5 kW. Is that correct? That sounds about right. Yep, so that gives us an answer in watts. We haven't used kilonewtons for anywhere else. So, okay, I'm going to move on to the next question. Oh, and it's the last question. 5C, yeah, okay, so this is it. We're coming home with a wet sail here. Okay, determine the force required to punch the hole. So, we've got so we know that stress equals force over area. That's true for shear stress as well. So what we're being told is that the plate is 3 millimeters thick. So I'm going to call that H equals 3 mil. And we've been given 2 values for shear. We've been given shear, the stress at the UTS equals 450, and we've been told the yield equals 310. I got these from a question. I think this one was from the trial, from the 2013 trial as well, that I posted and gave answers to. That's probably unrealistic. Shear stress is actually, for steel, is about 80% as high as its tensile strength. But don't worry about that. It's almost never going to come up. I didn't know that until I looked up just recently. Okay, so the diameter of this circle, we're told that that is 10. So what we need to find here is what I call the ribbon area. The ribbon area is this area here. That's what I call the ribbon area. So the ribbon area is going to be equal to the circumference times the height. So the circumference is going to be pi times d, and then multiply by h. So area is equal to that. So area is going to be equal to 10 times pi times 3, which is going to be 90 times pi, 94.2 meters squared. Okay, the force, now here's the question. when we're punching through something, we don't care about its yield. Yield is where the steel gives up, where it's no longer reliable. But when you're punching a hole through something, it doesn't matter when it gives up. You need to care about its ultimate strength when you want to punch a hole through something. So 450. Now it's in megapascals. This is in millimeters, so that means we're going to get an answer that's going to be in newtons. F equals area times stress, which is going to be area equals 94.2 multiplied by the, in this case, only when we're punching something we need to use the tensile strength. I included that to make the question more difficult. Okay, 94 times 450 is?
42,390.
42,390 newtons, which is equal to 43 kilonewtons. Okay. They asked for an answer in just regular newtons. That is the test, and I'm now going to go through some specific. Anyone got questions before I turn off the camera?
No.
Great, we can then just talk.
Like and subscribe.
I think it's time.